In this video we're going to look at problems that involve growth and decay, and this is a type of geometric sequence. So we're told the population of bacteria grows by 40% each day. We want to find the initial population given there are 120,000 bacteria on day 5. So if we call the initial population P, each day it grows by 40%, so it's going to be 1.4 times the size of the day before. And this is going to continue for 5 days, so it's the first day it is P, the second day is P times 1.4, up to the 5th day where it's P times 1.4 to the power of 4. And we're told that is equal to 120,000. So we can rearrange that to find a value of P, which will be 120,000 divided by 1.4 to the power of 4. So I can evaluate that on the calculator. And that gives a value of 31,236.98. Now, because we're talking about the number of bacteria, it would make sense if we then approximate that to 31,237, which is a sensible degree of accuracy. So this second question, we're looking at a financial situation. So £5,000 is invested at 4.5% per annum. Find how long until the investment has tripled. So we have an initial investment here of 5,000, and 4.5% per annum is 1.045 of the value of the year before. Now, unlike the previous situation where we started counting from day 1, here we're going to count from effectively year 0, because the £5,000 is invested initially, and then after 1 year it will be worth 5,000 times 1.045. After 2 years, 5,000 times 1.045 squared, and so on. So rather than using n minus 1 as we would do in the nth term of a geometric sequence, this is just n. And this is something you have to watch out for when you're dealing in financial matters. Are you starting on year 1 or are you starting on year 0? And it tells us that this investment is going to triple, so we want to know when it's worth 15,000. So now I've got this equation to solve, so I'm going to divide both sides of this equation by 5,000, which will leave me with 1.045 to the power of n is equal to 3. And then I'm going to take a log of both sides, so log of 1.045 to the power of n is equal to log 3. And the reason I'm going to take a log is so I can now use the power rule of logs to remove the n from the index. So I can write this as n log 1.045 equals log 3, and therefore n is equal to log 3 over log 1.045. So I can evaluate this. And that gives me a value of 24.96 years. But the interest is paid per annum, so 24 years, it's not quite 15,000. 25 years is the time where the payment is made, which is going to reach the 15,000 required. So my answer is 25 years. Now you might think we've rounded it to 25 years because it very nearly is 25, but because we wanted it to have tripled and because it's paid annually, we would round this value up even if it had been, say, 24.03. 24 years still hasn't reached the target we're looking for. 25 years is the time where that target will be met.